For example, it may affect NVIDIA. It may affect other AI chip makers. It may affect Microsoft maybe negatively because they're one of their competitors. But sources of news or surprises that affect only a small number of assets are called non-systematic risk. Okay. Now, the way Sharp set up, let's also define a. So we measure risk, in this case, systematic risk, because if investors are all mean variance optimizers, they never should hold an undiversified portfolio, which means they only carry systematic risk by beta, and we measure reward by so-called risk premium. For any asset or portfolio of assets, reward is expected return on that portfolio. I use P generically to designate a portfolio. If you have a single stock, it's a simple portfolio that has only one stock minus the risk-free rate. That's why we call it the risk premium. To what extent you expect to make money over and above the risk-free rate. And Bill Sharp basically says in equilibrium, all assets should have the same reward to risk ratio. So if you have assets, let's call I that's not equal to J, that means expected return on asset I minus risk-free rate divided by beta of that. By the way, this ratio is also known as the Sharp ratio, since Sharp came up with that ratio. And this should be true for all pairs of assets. So if you have 1,000 different assets, or technically speaking, you have infinitely many possible portfolios. If you take any two portfolios that are not identical, their Sharp ratios have to be identical in equilibrium. This actually allows us this requirement to come up with an expression for the expected return on any portfolio. Well, the requirement of equal Sharp ratios is valid for any pairs of portfolios. So is there anything that stops me from making one of the pair the market portfolio? No. So take any portfolio, the reward on that has to be the same as expected return on the market portfolio minus risk-free rate divided by the beta of the market portfolio. We have normalized the beta of market portfolio. This is equal to 1, right? That means if we solve for expected return of the portfolio, it's going to be risk-free rate plus beta of the portfolio times, this is the famous CAPM equation, okay? Sometimes this is also called security market line. We also have a special name for this, expected return on the market portfolio minus the risk-free rate. We call this market risk premium. I think sometimes it's also called equilibrium risk premium. So to what extent investors allow risky assets, investors are willing to take the risky assets, which is the entire market, over and above the risk-free rate. Since it's risky, they demand a premium. It sounds rather nice. If I have a means to estimate or guesstimate to what extent a given portfolio is carrying systematic risk, I can estimate what sort of expected return I should get on it. Generically, we call these models asset pricing models. So if I know the price now, I know what the expected return is, and so I can calculate expected future prices, right? We're going to have to do a lot of things to make this operational, but that's kind of the idea. So one thing about this is, if you guys remember, we did a model. Let me give that a little bit more curvature. This is the so-called minimum variance frontier, and the upward sloping part was the efficient frontier. Let's say this is the risk-free rate, okay? And if you did a tangent line, let me use a different color for that. It's a line that has a intercept at RF, but it's tangent to the minimum variance frontier. Turns out that happens exactly at the market portfolio. So this is the expected return on the market portfolio, and this is the risk of market portfolio. This immediately says market portfolio is efficient. By definition, it is anyway. And if we do the security market line, we plot beta